Hi guys, good afternoon, and thanks for your time on Saturday, taking your time to learn something new. And we have Sivam Sharma today. He is the co-founder of Tech Scalable, and also he's an author plus cloud architect, and he has spoken at different technical events. And it's not just he talks in the events, but also he makes people to be connected, right? Let me tell an example. So making people to be connected during a remote session, right, during an online session is not an easy task. He makes it does with the help of whiteboarding, right? Usually this whiteboarding happens only in companies where people will be sitting together, and they'll be whiteboarding, see, this is my idea, how it goes, and or this is the issue, this is where we are facing the stumbling block, how can we work through, or this is the new feature which we are rolling out. uh, like the things would be, the discussion would be going on. The same thing I see with Shivam Sharma, and that's not an easy task, guys. Only if you are pretty clear, only then it will be easier to go on with the whiteboard. So we are very happy to have you here, Shivam, and please take over the stage.
Thank you. Thanks a lot, Dinesh, for the lovely introduction as well. And thanks for inviting me. And a very big, and I welcome everyone. So thanks for joining us for this session. And let's get started. So I'll give you an introduction of what we are going to do. I'll set the context for the session, and then I'll walk you through the whiteboard as well, which Dinesh was talking about, and we'll go through it. We'll see it. We will go through the various things step by step. We'll understand what we do, why we do, and the today's session is more useful for it's useful for everybody. Even if you're new to the technology, then also it's useful for you. And even if you're working in the technology, then it may be more practical for you because we'll be discussing about the various tips and tricks and the design pattern which is required for doing practical ETL and data analytics with Azure solutions. So we will be using uh, the the recommended architecture provided by Microsoft themselves for ingesting data and for doing exploration and doing anything else. We'll talk about it: machine learning, data analysis, and so on and so forth with the Azure solution. Okay, so this is basically what we have to discuss today. So the session will be slightly, you can say, at times it might be a little overwhelming as well because we will be going in the technical depth as well, and we will also understand the various concepts. So there are a lot of things to understand in a shorter span of time, and the session will be there for next 90 minutes as such, including the Q&A. And if and keep on asking your questions, and we have the chat window with us, and we'll answer your questions on the way also, and you can and we'll take the questions after the session as well, or at the end of the session as well. So this is something which we are going to talk about. I have this architecture over here, so there are a lot of things which we'll be going through. So I have the skeleton of the architecture already with me over here, or this is really the we'll put steps over there. We'll go in depth. We'll see what we are doing, how we are doing it, and and I also have the implementation of that somewhere over here, and we'll go through the code as well. We'll go through the various functions, and we'll go through all the details of the things as such, right? And I will also give you links for which you can use post session for replicating what I did, and also for you can say understanding what I did in a more slower manner, or maybe in more structured manner as well. So we'll provide the links and the repositories and so on and so forth. Okay, so let's get started, and we'll understand the problem statement first. And once we understand the problem statement, we'll understand the concept. And as soon as we are able to get started with the concept, we will jump into the implementation on the way along with the concepts, and we'll start reading the code and everything. All of that will start happening after that. So the most important thing is the problem statement of the customer. So let's spend some time into doing that. So if I take you to the right page, okay, let me just quickly move this on my secondary screen, and I'll duplicate the page which I want you to uh, which I want to use right now. So check this out. So the the problem statement which we are going through is provided by is a is a practical, is a real time, or uh, it's a implementation. The implementation of this of what we will cover is done by Microsoft for their customers, and Microsoft suggests this generic architecture for everybody, so that uh, even if you're, let's say, you have the direct support of Microsoft, even if you don't have the direct support of Microsoft, you can definitely use the various patterns over here to do it the way it's supposed to be done. That's the logic behind it. So we'll go through the problem statement first. So this is a repository. You can also just Google for this and find it. Otherwise, I'll also put this link in the chat window, and we'll also post it if you have found me from LinkedIn, or if you have found us from the meetup page. We'll also post it over there. So don't worry about that. But let's focus on this part. Now the scenario first. Now so today I'll zoom in so we can read it once. Okay. Now check this out. So you are a data platform architect for a global data analytical company, and you, as the company's business is booming, you want to implement a new system that can collect the telemetry data from hundreds of thousands of devices from the growing customer. So your company is collecting data of other companies, and the number of companies whose data we'll be collecting will grow in size. So the solution which we have to design has to be very scalable, and it has to be scalable in all the individual from all the individual point of, you can say all the solutions, all the elements which are there, all the components which are there, they all have to be pretty scalable. And it's not that easy. When we start ingesting data, duplicate rows are there. When we start ingesting data inconsistency happens. Some of the files are they go corrupt. We have to put the retry pattern. We don't want that. The let's say you have some ingestion layer solution like Kafka, or maybe you have event hub through which that's acting like the broker over there, or for the event log. And now you do not want the consumers behind it, or you do not want if you're streaming the data as such. So the other systems which are catching the stream, they should not get overloaded because of various layers which you have in your solution, because it's possible that you are doing some transformation in Spark, and Spark is pretty powerful, and then when you write that output in another warehouse, then things get choked over there. So we have to think about all the things. So sorry, my voice is slightly off. Now, okay, these devices, they generate the telemetry across multiple, you can say, they're streaming data 24/7 over there. Now, and through multiple continents also. So members of your team, so we have both the data analyst and machine learning specialist uh, for whom this solution is designed. And this the implementation which we are going to cover is a real implementation, and only the name of the customer has been removed uh, to avoid from the privacy's point of view. But and definitely some other things will be, definitely the data is also a dummy right now for us, but the architecture is still the same. So you can use that. Okay. Now, anyways, so we have to analyze the data which is coming in as soon as possible. The telemetry data which is coming through solutions such as Kafka or Event Hub. So, or IoT, it can be IoT Hub also, right? For IoT scenarios, definitely that as well. Now, shared across different customers to reduce the operational cost. After you receive the data, you will need to separate it based on the company and the product type. So one thing which is mentioned is that the to reduce the cost, the backend is shared across for multiple customers. We are not creating individual implementation of the architecture for every customer, because then the cost will just skyrocket. So we are sharing the backend architecture, but still we have to be scalable, and we have to make sure everything is isolated, and uh, all the company norms are followed over there. Now, after you receive the data, you need to separate it based on the company and the product type and save it into different data repositories. For customer privacy, each data repository has to be independent access control should be there. So we also have to think about the access control from the Active Directory's point of view, Azure AD, if you know what Azure AD is, and we also have to talk about the access control from service principals point of view, or from the point of view of Key Vault as well, how things are going to be in Key Vault. So okay, now also some data is collected from various third-party companies using other options as well. So they provide the collected data in a small batch every second, and it is stored in the data lake. So apart from the streams, we are also getting data in batches. And the solution which Microsoft suggests for companies who are working in similar fields or who have similar problems is this over here, which we have further summarized in our whiteboard. So we'll go through that. We'll go through individual points over there. We'll see how it's supposed to be done. But I'll just zoom in over here and I'll just walk you through this first. Okay, so we are getting data from various sources. On the left hand side here, you can have Kafka clusters or Event Hub can be there, or Data Factory can be there, or any other service might be there, which is throwing the data inside the data lake. So we have two different data lake. One is for landing and one is for ingestion. So when the data goes in the landing over here, then on top of this data, we basically have in this data lake over here, we have various directories over there, various containers will be there inside it, and we have to take care of the data accordingly. So I'll do one thing. I'll just start relating with the Azure portal as well, so I don't run out of time later on. So just want to show you a couple of things on the way. So that's my Azure portal, and it took me around it took me you can say maybe uh, so the documentation which Microsoft has provided, this documentation is pretty amazing, but the but there are some breaking changes which has happened. So because of that, some troubleshooting was required. So it took me some time to do that and keep everything to make everything run. So I'll use my code for reference, and I'll also start just I'll show you the various steps in the Azure portal as well. So that's my Azure portal, and I'll just take you to my resource group, which I have set for this demo as such, and we'll start relating with it, right? What is where and so on and so forth. So the main resource group is this one, the ADX demo RG. That's the one which we are going to use for the entire session, and this is basically my dummy account. So I use this account for demos and all that. So I also may be able to show you how the key management will be done practically, and we'll see if we can cover everything, right? So I have to slightly zoom out here. It's too zoomed in for me to also look at the screen right now. And if I just show it to you, so let me just arrange them in the right order. Okay, so check this out. So that's the landing data lake. This is the one which we have over here, this one. And this is where the data is coming in from various sources, and it is landing over there inside this landing data lake. Now, if you're aware of data lake, the data lake is the replacement of HDFS in the cloud platforms, and data lake is available in all the clouds, right? So the names will be different, but you will have the data lake equivalent in all the locations as such. So the data from the left hand side, it may be coming via batch or in batch mode. So we'll just think it through. Maybe it is coming from various locations over here. So maybe a factory flow over there, or often customer. So this is customer 0. This is customer 1, customer 2, and so on and so forth. So from various location, data is coming in batches as well over here, which we actually, I have not implemented that. Like, how is it coming in? It's part of, you can imagine it to be coming through data factory using one ELT logic. or it's not very difficult to do that. So and if you find me on LinkedIn, you can find me my previous other sessions as well, where we have covered data factory in way more depth, right? So we will skip that part and we'll go in the advanced concepts for the day. So just to keep things into perspective, we have data which is coming from various sources over here. Different locations are there. Maybe this is a factory floor for the company number one, customer zero, and this is the factory floor of the customer one, and this is the factory floor of customer two, and so on and so forth. So now when we talk about what we might be getting, structured, semi-structured, unstructured, any type of data might be coming as such, and we have to think about solutions which can handle all three type of data as well. Now, so if we do the batch ingestion of the data here, ADF or Azure Synapse pipeline will be there. If you know what is data factory, or if you know SSIS, then that is data factory. If you have worked with Airflow, uh, Airflow also is similar to data factory, or Apache Uzi is very similar to data factory. So if you know those technologies, then data factory is similar to them. Otherwise, just look up for any other session which we may have done before. Now, okay. Now, apart from this, what happens if we are getting data uh, from from as a stream as such? So I'll just put things into perspective over here, and then we'll go into a diagram. But let's say you're getting data from IoT sensors, then we use Event Hub. Oh, sorry, we use the IoT Hub over here. This one, Azure IoT Hub. So Azure IoT Hub and Azure Event Hub, these are the two solutions which are built on top of Apache Kafka, and both of these solutions are PaaS solutions in Azure, and like this. And the backend of both of them is Apache Kafka. So the differentiating factor between these two will be that Event Hub is one directional. Event Hub ingest the streams, the events as such, and IoT Hub is involved in IoT scenarios where you are getting the data from any, let's say from a rod pump, or maybe from from a conveyor, from the sensor in the conveyor belt, or from maybe from a car, and so on and so forth. So in the IoT scenarios, IoT Hub is used over here. It is having way more functionalities versus Event Hub. It is specialized for IoT scenarios, so that's why we use it for that. Event Hub is not supposed to be used for IoT scenarios. It doesn't have those functionalities. It's not designed for that. And IoT Hub is also bidirectional, and Event Hub is single directional. So if you are getting your data from, for example, from Twitter, then you will be using the Event Hub over there. So like this, or from any other mobile application, and the customer is clicking on this mobile application in this point in time, then in all these scenarios, we'll finally end up using the Event Hub over there. And if we think about the IoT scenarios, then IoT Hub will be there. So this is where we are differentiating between the sources, as that these are the stream sources. We are getting stream from there, which we have to work with today. And we also, the customers are also dumping, we are getting the data from their locations in batch mode as well, using something like data factory. So I'll just do it a little more cleanly. Just give me a second. So this is data factory over here, or Synapse pipeline. Okay, now that's on the left hand side, and data is finally coming in, right? We are focusing on what happens as soon as we get the data, uh, versus the other part, like over there. So now we have this ADLs landing over here. So this is a landing zone where the data is coming from various companies, and it is going inside that uh, uh, ADLs location. So if I show that to you, I would just take you back to my data factory, and we'll find the page I wanted to show you. So this is that ADLS landing. ADLS stands for Azure Data Lake. It's the replacement of HDFS. It doesn't have any upper limit. You can store any amount of data over there, and pay-as-you-go service, and pretty good, right? Okay, so if I click on it, basically this is where data is going in, and we have created different containers over here. Check this out. So if I click on this container, you will see that I have two containers over here right now. The third one is not, that's a log container. I didn't make that. So this is a data container where everything is falling. And the if something fail, then this is the one where we will implement the retry behavior later on using Azure function to ingest the failed or the data which couldn't be processed because of some XYZ reason. That data goes there. Okay, so if I click on the on this one, okay, so I have this is the telemetry directory over here. This is the main directory where the telemetry data is coming in right now. That checkpoint is my Spark streaming checkpoint. I'll explain in a few minutes what is the meaning of that. So this is where we are getting the data. So 2022 folder, and a couple of more things over here. And let me see, what have I implemented. Okay, so this is where all the sample input data is there. Now for this demo, I manually uploaded the data. There is I don't, as I was already mentioning, that I haven't implemented the left hand side of the solution of how the stream is coming in, or how the batch is going inside that we are just assuming has been done. So we finally got the data. So today I manually uploaded there. So the logic starts from this point onwards. Now, so if you check this out, see, there are a couple of things which should happen. Like one thing is, like, when we work with big amount of data, if we are thinking of some sort of pre-processing to be done on the data, like this customer wants us to divide the data company by company and event by event also. Like, there are various type of device events which are coming. So data should be segregated, and finally different tables should be there somewhere where we have to ingest that data later on. Now, to do that, if when we work with big amount of data, we also need a cluster which can, we also need the compute solution which can actually work on that volume of data which we are dealing with, volume or velocity, and both will become a problem for us. So we are going for the Spark based solutions. Now, the if you know how Spark based solutions typically work, there are two type of cluster managers over there: yarn based cluster manager or Kubernetes based cluster manager. And the yarn based cluster manager is the one which is right now available in all the solutions in Azure, and the Kubernetes based cluster manager is something which is being implemented by various companies, but it's, if you have to do it, you have to do it with Kubernetes services, AKS. So the Spark solution which we have in Azure, we so there are two Spark solutions. If I avoid the edge, if I just don't cover HD inside, the two you can say managed services which we have will be Databricks, Azure Databricks Spark Cluster, and Synapse Spark Pool. Synapse Spark Pool. Now both are pretty good, uh, and we can definitely compare them like this versus that, but that's not my primary concern right now. I want you to use any Spark cluster. You can make a VM and install Spark over there, make a cluster of VMs and install Spark. But finally, we need some big data compute solution which can deal with the volume of data which we have. Now, today we are going with the with Azure Databricks Spark, which doesn't mean we cannot use the other one. We can totally use the other one as well. And Synapse is a suite of product. So Synapse is like one-stop shop for all the analytical requirements. So you can look for what is Synapse, what is Databricks separately. And Databricks is from a company called as Databricks, and they have a tie-up with Azure, so Azure Databricks as such. So it's a fully managed solution. So that's the one which we are using. So what I have done is I have created this Spark cluster, and which looks like that, and it will look slightly better in my in the portal. So we will just duplicate the screen, so the tab, so we don't have to go back and forth many times. And I was hoping it to load a little faster. Great. Okay, I think just quickly check my. Oh, great. Just give me a second. Let me just also enable start one ping. Okay, just to check my monitor network as well. Okay, now notice this. So I am just taking you to the to Databricks, and we'll have a look at it. We'll understand what it does, why do we have it, why are we using it, how will it make things scalable, and so on and so forth. So this is the one which I have implemented, and there is not much logic right now in this. You can simply click on create and you can make the cluster. It just takes some time. So this is the workspace. Now if I launch the workspace, all the management of the Spark is supposed to be done from this workspace, which will load over there. Now if you have worked with the uh, Databricks before, then you will be familiar with it. Otherwise, I'll just give you a quick walkthrough of it. So if you can see, we have the the code will be there in the workspace section, and this is where I have created the cluster. I actually have created the job cluster. I'll explain what's the meaning of job cluster, and and I think it's still running. So we'll go through it, and this is where jobs are there, and I'll show you the job which I already have with me. That's the job which I started, so I can show you how it's looking like. And if you want to make a cluster, normally you can just click here, click on the create cluster, give the cluster name. This is where we have various Spark runtimes over here, and machine learning runtimes with GPU, or non-machine learning runtimes without GPU functionalities, but with Spark functionalities. So so uh, I'll show you the file which I have over there. So this is one py file which we have here called as data preprocessor.py. So what this file basically does, whenever the data comes in the input landing zone, the landing zone which we have in the ADLs, when the data comes over there, it starts reading the data from there, and it starts basically a Spark stream from there. So we will understand what's our Spark stream, and then it splits the data based on company ID. So various companies' data needs to be segregated and stored separately. So that's what it does, and it will also segregate data based on different company IDs and the type of events which are there for those companies. Now, once it has done that, it basically writes the data back in the target folder. So target folder is the other ingestion data lake which we have over here. This is the target. Here we'll have the target folder. We'll go and look at the target in a few minutes. Like what is there? How will it look like? So if I take you back to that now. Okay, so the pre-processing solution which we have is doing two things right now. It's segregating the company's data, different companies' data, and also it's further segregating based on the type of device events which are coming for that company, right? Two things, and then it reads and it writes. And if something is bad, if there are corrupted records or bad records are there, then that goes in the bad records location. So that bad records, like something which cannot be pre-processed because of maybe it's not correctly formed, because of some XYZ reasons. So that we are storing separately, and we will have a different logic around that to ingest that also in a later point in time. Or if it doesn't ingest, then we also will have a logic to just inform, you can say, the administrators that okay, we have tried 3 times, 4 times, 5 times, and we have done whatever we could do. The automation script got executed on the bad records. Nothing can be done. Now you take care of it. So that we'll handle the bad records as well. Now, uh, okay, so if I just take you back to to the architecture. Now, if we talk about Spark, now there are two things which makes it very fast. First of all, unlike MapReduce, Apache Spark is doing in-memory computation. So definitely you need a lot of RAM as well to be able to do that. But it does it very fast. So if you compare MapReduce jobs with Spark jobs, so MapReduce is Hadoop jobs. So if you compare the MapReduce jobs with Spark jobs, the Spark jobs are going to be somewhere around 10 to 100 times faster than the MapReduce jobs. Minimum, that at least they will be 10 to 100 times faster versus them. Now there are a couple of reasons because of why it's so fast. First is definitely in-memory computation. So in RAM, in memory computation. One problem which was there with in MapReduce is that it does lots and lots of disk operations, like the partitions or the outputs of your map jobs are going in the disk, and then it's read by the other mapper or other reducer, and then so many disk IOPS happens, it slows down. So that's one thing which has been taken care in Spark. Secondly, the concept of RDD is also resilient distributed data sets is also the backbone of Apache Spark. It will provide us the capability of doing lazy evaluations. Like if something, so lazy evaluation means that if something needs, for example, instead of if I give you a piece of code, instead of just executing it blindly and moving the data around, lazy evaluation in English means plan it out. You can say optimize it, see if we can have some stages, if we can have some sort of let's say task, and then and only when required, then only start the execution. If not, then just return the RDD type. So so if I have one input, let's say RDD, then we'll get one output RDD out of it, but nothing will actually happen inside the cluster. So those type of functionalities or capabilities started happening in Spark, which is different from which is just different from the MapReduce engine as such. Now, so if we think about Apache Spark, it's going to be 10 to 100 times faster. This is one thing which we are looking for. Secondly, the scaling functionalities. Now, what I can do is, uh, if I take you back to the cluster over here, see, and if we click on the cluster, you will notice that we have this auto scaling functionality here. We can say enable auto scaling, and we can specify the min and max. Sorry, we can specify the min and max over here, and automatically it will scale based on the capacity. We definitely should do the capacity management ourselves. We should know what we are doing, how many executors we want, how much RAM do we want over there, how much cores we want. But the cluster is pretty scalable. So even if so for the client which we are talking about right now, even for them, when their business further boom and they onboard more customer, we will be able to we still will be able to scale the job, and we will be able to handle that uh, if that's going to happen. Now, okay, now, so I don't want to make that cluster, I just wanted to show it to you, that that's one thing which where we are thinking of scalability. And in typical you can say Spark job, this is going to happen. You will submit the Spark application, and we have few components over here. Now it will take you more time to understand these components, but I'll summarize it for you. So we have the resource manager over here. It will basically ask the node managers in the worker nodes over there that okay, and then go and launch the app master. So here app master will come up. App master is responsible for the application's lifecycle. Now inside the apps master is where we have the driver. Driver is very important. Driver is the one where we have all the good things of Apache Spark. The DAG scheduler, we have the task scheduler, the backend task scheduler as such. So all the things happen inside that driver. And then once all the negotiation is done, the executors will come up all over the cluster. So see, you see these executors which I'm trying to create over here. So these executors are the ones where your job will be executing. So one task is executing here, one task is executing there, one task parallelly executing here, maybe one more executing over there. So what we try to do is we break the job. We don't do it. We let Spark do it for us. We let the DAG scheduler do it for us. So what DAG scheduler as part of the driver or part of the Spark solution or Spark functionality, what it does, it will break your data into various stages, and these stages which you have will be further. Sorry, the job will be broken into various stages, and these stages will be further will be having task inside that. So there is a logic behind how stages will be created by Spark. There is a logic behind how like that the task which we have inside the stage will be running parallelly. So I will leave that onto you to find my previous videos on this particular concept, and you can further go in depth over there. And we'll just say that we have taken care of the scalability problem, at least from the point of view of the preprocessor, uh, which can which will take care of the you can say segregation of the data of the company in various different files and different folders, and will also take care of the corrupt rows over here. Now, one thing which is very important is we are using a claim check mechanism to execute this. We So to understand the claim check mechanism, I'll just put that mechanism over here, and that's what we have implemented over there. Now, see, let's say this is the publisher of the data, or that's the sender of the data over here. So sender of the data, and here we have the consumer of the data over here. Now, what we are doing is we are doing a sort of valet parking right now, and the logic which we have implemented is that we'll have this queue in middle. So that's the data repository like this over here. So when the senders they send the message, they actually upload the data because data is big in size. The data gets uploaded in the repository. So this is where the big files are coming up. But we have messages in the queue, and these messages will be having the, you can say, the URLs or information about that the data has been uploaded, and we will have further logics over here. But finally what happens is that the receiver will be able to, or the consumer will be able to understand that the data is arrived and I have to start processing it based on my capability as such. Or so instead of directly communicating or sending or doing something, we are sort of decoupling both the layers which are there. Now, that's the one which is recommended by Microsoft, and we have already implemented that. So we have used storage account queues to do that. Now, so storage account queues are basically uh, it's a queue which we have in storage account, object storage, and the message size of this is small, 64 KB, and the length is pretty big. So the storage account queue can be as big as 500 terabytes. So this is very scalable over here. And if you are aware of storage accounts, so this is built on top of Azure storage accounts. Okay, so storage accounts, and storage account is highly redundant as such. We have various type of redundancy options over there. We have ZRS, which is actually slower. We have GRS, or we have other options as well, RAGRS, and so on and so forth. So this doesn't take care of the scalability in this point in time, but it definitely make sure that uh, because this is that neck which we have, or that's one of the choke point which we have right now. Not really the choke point, but the but one solution which is connecting both of them. So the redundancy enables the high availability. So over here, so they have 3 copies. This is having 6 copies of the data. This is having 6 copies of the data, and other options are also there which you can use. Okay, now so the logic which we have implemented is that uh, the so Apache Spark is going to read the files as a stream from the source of the data, which is the folder called as data, and the data will be going inside that, and that's from where it will read the stream. So this is the read stream arrow. It's not through the queue, right? It's not from there. So this is the read stream arrow. Now, if I show you that part, like how have we done it? So it's a simple Spark. Okay, now before the simple part, there are a couple of more things to ensure that all the customers we don't we keep the solution as secure as possible. We have already implemented the secret scope, and we have already implemented the key vault based integration. So if I show you the key vault based integration, then the all the keys are there in key vault right now. So I have different key vaults uh, for my solution right now, and I will just show you the. I'll show it to you once. Okay, so okay, Databricks key vault. Let me think, which one am I using? I have two of them right now. Let me click on this one, and I think it's the other one. So secrets. Now this will not be visible to normally. This will not be visible to you in your companies, but I actually have the rights right now. So I can see, I can show this, but it's not exactly the one which I wanted to show. But just to give you an idea of it, we have kept all the variables, all the secrets are there in key vault. So that's the landing zones connection string. So landing zone is the the landing ADLS which we have right now. So that key is over here, which we are pulling later on. Now, and I'll just walk you through the other data key vault which I created. Yeah, the first one is the one which we are using. That's the correct one, the one which we just saw. Okay, now after that, we are pulling all the various secrets from the key. So we have created the secret scope concept, and we have the source file location as well, which is the ADLS location. We also are getting the you can say, I'll just zoom out once and let me just scroll up, and let me just go here. Okay, and now let's see. Okay, so checkpoint locations are there. Stream file locations are there. I'll walk you through the main part first. This is where we are setting the config. Config will basically ensure that we are able to connect with the ADLS location, and that's the Spark configuration which we are putting over here. And this is where we are using the keys which we have kept in the key vault as such, like the secret of that, uh, and so on and so forth. Okay, now whenever we work with the streaming data, we actually have to define the schema which we are ingesting as such. So we are doing that. It's not mandatory for your batch jobs, but for your stream jobs, you have to specify that. So we are streaming the rate, we are getting the stream, we are defining the schema, and then basically we will start the spark stream.read. So this particular spark.read stream is actually what we are representing over here with that arrow, that it will start the will make one job which will start reading from the source as such. And this is the source where the company's data is going. So that's the folder, the red folder which we have is actually where that is pointing to right now. What it does, it is reading all the JSON files which we have over there and other files which will be there. And it's also max file per trigger. Like this is one of the variable which we have, like so when it starts reading, how many files should it read in one go? Like should it read one file in one go, or 5 files in one trigger, or 100 files in one trigger? So it depends on many things. If you give set a very high value and you have very less resources, you may also get some out of memory errors also. So now what happens with the bad records? There is a different mechanism for that. Now we split the data uh, based on the customer ID. And once we do that, we basically start going and we'll append the data in the output location. So now this is where we start, you can say from where everything is. Uh, 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 that's the final the calling location of the functions. But we actually are not running it manually. What we have done, we have created one job over here. So this job which is created is will execute on a schedule as such. Now other things are totally possible. You can uh, run it, you can change any value which you want in any location. I think I forgot it to close it. It's running since last 9 hours, so it's great now. And okay, and just to show it to you, so the cluster is the same cluster I was showing you earlier, but the cluster was configured for the job. So it's a job cluster which will automatically come up, and because it's a stream job, it's still running. Otherwise, it would have been terminated automatically. And that's something which we can also automate there to terminate the job once it has finished executing now, or someone can trigger it like event based triggers. So for now, I'll just stop it, and I don't need it to be running anymore. It has done its job. But if I show you some other things, it will show you other details over here and XYZ. But finally, what it did is the data finally goes in the ingestion ADLS, and the bad records goes in the bad record folder. And this is the output data which needs to be ingested by the other solutions, which our data engineers, data scientists, machine learning engineers in the company will be using. Now, there is one question in the chat saying, "What's a spot instance?" I think you have seen the spot instance on this page, on the cluster page. And if I click on it, this is where we have it in Databricks, this one. So what this basically does is, if I don't use it, then these are dedicated machines, like 2 minimum, 8 maximum right now. So when I'll create this cluster, 2 will come up. Now that's dedicated for me, and it's associated with me, or it's allocated to me, and nothing else will happen from that point onwards. I can normally run my jobs. If I use these spot instances, then the logic is that the if Microsoft is having extra compute available in that region, they will give me the machines on a discounted cost. But the tricky part will be that if they need the compute back, they will take it back. So if I do not have mission critical production job which I need to execute in this point in time, then that's fine. I can schedule it for the I can have some sort of logic that, okay, use spot instances. So even if, let's say, even if the machines were taken back, then our job, it doesn't matter. The capacity will come down, but overall, and the cost will also come down. So spot instances like that, discounted machine, if the extra compute is available by from Microsoft, then that can be used. Okay. Now, let's have a look at this ADLS ingestion over there, where the output is going. So I'll take you back to my Azure portal, and we'll go to the other data lake. So this is the source one, where the input data is going. That checkpoint is for the Spark streaming. Like if you have read till 55 line, obviously you want to read the 56 or 56 file, or from that point onwards. So that checkpoint is being used by Spark streaming to put the checkpoints over there. Now, if I uh, go to the other data lake which I have, which and I'm pretty sure you are aware of ADLS Gen 2, right? How do we make it? So ADLS Gen 2 is enabled from the storage accounts. That's why I have clicked on the storage account option over there. And ADLS Gen 1 was created separately from that the plus icon which we have on the top. The old one is already deprecated as such. The support is still there. So use the Gen 2, not the Gen 1. There are technical differences between them, and lack of redundancy options in the old one is one of the reason why we have the new one now. Okay, so this is the next one. So this is where the output of the Spark cluster goes in that container. And okay, so I have the same container here called as data, and this is a Databricks output over here. That file I manually uploaded to check it out, like it runs or not. Like I was just checking it out. This is the ones. Okay, three queues are there. Let me show you these queues as well. I'll explain them. We are just going towards them now. So you see these. Uh, we have various queues over here, more than three, and I just want to show you the other ones also. I had three in the landing as well. So I'll tell you what we are doing with it. Okay, three queues are here. These are the ones by which we are having the name. These are the ones we are using over there. I'll explain why we have them, why we need these queues. But you already got the understanding that we are doing a lot of valet parking type of concept. We are not overloading the the consumer or the reader. We are doing a claim check. Now, if I take you to my ingestion data lake, that's the output folder of Databricks. And if we go inside it, you will see that what I have done, that's the one that's a random one. I manually uploaded that. But these are the ones where we have three different folders over here. And these three different folders will be read by three different queues later on. Or you can say the claim check will be done through the different queues over there, which are coming as such. So it's for the purpose of filtering also, which we, or you can say high availability as well, for why we are using three queues as such. Now I'll just click on one of them, and I'll just show it to you that how has Databricks segregated the data. So if you can see company ID 0, company ID 1, company 10, 12, and so on and so forth. So the the data of various company has been segregated in different folders as well, and we are reducing the cost by sharing the backend, but still we are able to keep it segregated. Now inside this company's data, if I click on any one of them, company 0, uh, the company ID 0, and we are using this particular logic later on, this ID key as such over there, right? We actually are using it. Now, then we have different tables over here, you can say, for this customer. And if I just see if I can show you the data, it was in JSON format. So I should be able to just click on the edit option and show it to you here. And so these are sort of dummy data, so it won't make much sense, but you can see that we have the company ID 0, this represents like a nested column, like a complex data. So inside that column, we have key value pairs over here, some uh, uh, random values. Like I don't have a key right now. Like for example, key can be that temperature. The other one was vibration. Third one was some sort of power coefficient of the IoT device or XYZ. So right now we just have more data 0, more data 1, more data 10, more data 3, and others will be there, just randomly generated data. Okay, so this complex column is there, and we want to understand that we can deal with this, and we'll be able to deal with this data, which is can be nested over there. And other attributes are also there, created at some time. Device ID is contoso device number 817. So 817 can be some IoT device somewhere in contoso's company. And device sequence number is this, event ID is this, and some sort of event type is there, CO2, and the as over there for the for the company's point of view, and some other values are there. Now okay, so this is just one of the sample files which I have configured for us to understand. And if you can see that for various companies, we have it over there. Now, okay, now what do we do? So the raw data came in the landing zone. It was pre-processed by Spark. Spark was pretty scalable. We were able to pre-process it. The output finally went in the ingestion landing zone. The corrupt rows are the corrupt records are stored in a different directory in the landing zone, which we separately will handle using functions. But the data which was properly partitioned based on company ID is now in the ADLS, uh, the other ADLS, which we are calling as the ingestion ADLS. Okay, now this is where the entry of Data Explorer comes. Like we'll understand what is this Data Explorer. We'll understand the middle part of it, like how are we connecting both of them and so on and so forth. Now, Data Explorer is a service which Microsoft themselves is heavily using in all the solutions which you, or most of the solutions which you are aware of. So if you know about Intune, the MDM solution from Microsoft, mobile device management solution from Microsoft, right? Intune, the one which got renamed. So that heavily uses Data Explorer also at the backend. Various other monitoring solutions which are there in Azure, the solutions where alerts can be created or where queries run, and then maybe some sample output comes, like the type of solutions which Microsoft provides to us. They also heavily use Data Explorer at the backend uh, to provide those services. And we also have the capability of creating our own Data Explorer instances and work with it. So what we are going to do is I'll just show this to you first, and then I'll explain the other details over there. Now I have it. I This is the one which we are using. That's the other one which I just was testing on. So this is the one which we finally want to use. So what I wanted to do was to create equal number of. Okay, so this is my Data Explorer cluster, uh, and uh, if I just want to uh, show you a couple of things here, if I click on scale up, let me just create one more. Just want to show you the how it will look like when you will start creating it. Then we'll come back to the one which we have already deployed. Okay. So if you create Data Explorer for the first time, this is how it will look like. There you go, you click on create, and then you have to specify all the configuration details over there. So yeah, the cluster name, why what I'm going to do with it. Do I want it compute optimized, storage optimized, heavy compute optimized, and so on and so forth. So is it going to have how many cores, like 16 cores, small cores, and then more specification like uh, that how much size, how much what's the VM size which is available, how many GB of RAM, and other things are there. Now once you select your suitable size, right, you can also specify the availability zones where it will be high available, like it will be made high available. Regional high availability will be there by selecting it like that. I Mine is not high available right now. I was trying to reduce my demo cost, so I kept it one, but you keep it three in your production environment. Okay. Anyways, in the GitHub repository, which I will provide it to you, the one from Microsoft, in that also they have kept it one, but that's one of the so it's not really HA in that. It's just having one copy in one of the availability zone in East US. So you keep it three in your production environment. Now, scalability is the one which we can also set from here. Like how many minimum instances of compute do you want for Data Explorer? How many maximum do you want? Can it auto scale, or do you want to manually set it? So these settings are also available. Now, what are we going to do with it? Stream ingestion, or auto stop the cluster, or some sort of delete of the data, purge of the data. Those type of high level settings can be enabled, disabled. And encryption, MSI, we'll skip for now. The public endpoints, definitely in the production environment, it will be the other one. Public endpoints will not be enabled. And then finally, you make it right from here. Now, once you make it, it's going to look the way we were seeing it before. So this one. Okay. Now I'll show you one more thing. So I did the entire setup from using Azure PowerShell and CLI. So so for example, if I publish it in GitHub and make a README file specifying uh, the the PowerShell versions, then you can simply just right click run all, and it should be able to work as such. So just want to show you a couple of things over here. So simple, we have to add a couple of namespaces to make the entire example work. The Kubernetes ones and all those are not for our session right now, but we'll just use the other ones uh, as such, Databricks, compute, and so on and so forth. And these two are specifically for our demos as such. And we do not want to hard code anything. So we have created one configuration file, which is open actually over here. And all the details are inside that configuration file. So anything which we are working with, all of that. So application ID, the display, the display name of service principal, secrets, secret value. So all of this information is what we have further secured inside the key vault. So right now when I was developing it, so it's over here, then I have pushed it inside the key vault, and then in the application code we are only using the parameter injection, or we are only injecting the values from pulling it from the key vault after uh, specifying the access policies over there. So all of these things are over here: resource groups names, the data lake name, some prefixes, like landing zone name, uh, right? One more thing, see, another very specific problem which we will face in real environment is that when you will work with a lot of data, the you actually have to pay for the storage and transactions, right? So if you keep your data in the ADLS for way longer than required, then the storage cost will mount up because data is continuously coming in from various sources, right? So it's a big data scenario. Data goes cost goes up pretty high, pretty quick. Just the storage cost of it. So to take care of that, we have implemented, it's recommended also to implement a lifecycle management policy. So lifecycle management policy is an automation which is already there inside storage account. You just have to set it up. And once you set it up, it will automatically do things for you, like move the hot blob into cool blob into archival blob, or delete the data. So the one which we have configured right now is the one where we are deleting the data after 7 days over there. So which is what was configured from the as such somewhere over here, this one. So after 7 days, the telemetry data is going to be automatically removed by the lifecycle management policy, which should load in this page here, that one. So this is the one which we have set, and the value is 7 days for that. Some other configuration details to for key vault, some more for the Explorer. This is for Databricks, and so on and so forth. Okay, so that is being used heavily over there. Now, okay, so this basically we don't want to hard code the anything inside the code. So the configuration file will be managed separately, and we'll follow the 12-factor app approach where we have the config file separate. Okay, now the normal things for a lot of setup, you need to have authentication authorization. So service principal based authentication authorization is what we are going with, and we will log in with service principal also. So we'll authenticate also with service principal and authorize also. So everything. So it doesn't. So when you will practically make it work, it will not require human intervention to run anything. Service principals will be used to run it. Service principals are the service accounts which will do that. So we are doing all of those type of things over here. And so we create the landing zone first. This is the ADLS landing zone. Then these are the file systems which are coming over there. That's the lifecycle management policy. This is where we have some more file systems in the ingestion landing zone. This is where we have the key vault and created, and we are pushing some, we are setting some policies for who can access key vault, which is very important over there. Then we have little more creation of the other key vault, which is not necessary. I'm not sure why I did it. And the event grid is another service which we are using. I'll explain that. But if I just walk you through and show you till where have we already covered. So all of this is done, like we have created few tokens as such to read the data from. So Databricks will use these tokens to read the data from uh, ADLS, and also when it's writing, it will use these tokens to write into the ingestion zone over there. So, and other systems will also use these tokens. So we have pushed all these tokens inside the key vault. So this is where we are defining all the things, and then we just deploy them to the key vault. And we are using the ARM templates for that purpose. ARM template is lying somewhere on the left hand side here. Right now, just lying there. Definitely, you should organize it better than what I have done right now. So I was sort of running out of time. So I just did it like that. Okay, now, anyways, so the okay, this is Databricks, still Databricks, and all the things in Databricks is done. So let's scroll down and let's find where we have the other part of it. So this is what I was telling you about, that we are not hard coding any information of the customers. We are using the secret scope concept, which is like which is actually this. Uh, if I just put it here, it means that the that the key is here, but the key is, it goes inside the secret scope like that. And secret scope is what we use inside the code like that. So that middle thing is secret scope over there. So it's for the for that. Now, okay, so let's skip the Databricks part. Okay, finally we come to the Azure Data Explorer, and we start working with it. Now, over here, if I Okay, so if I just keep it here and I'll take you back. So the Data Explorer is created in this point as such. And what we have done is for every customer, we want to create one database inside Data Explorer. So right now I have around five of them, but we want to segregate the data of the customer. You cannot keep them. If you can say the databases are supposed to be segregated. That's what I was planning for. But I had more than 100 customers, the 100 databases were there, and just to reduce the cost, I didn't go for the entire 100. I went for some four or five databases over there. So if I go back, take you back to my Data Explorer, you will see that I have these databases here, and with one Python loop I created 100 databases there, like 0, 1, 2, 3, 4, each every one for every customer. Then finally decided not to do that, and I just deleted the others. And I have for this example, I'm just using one of them where I had more data. I'm not sure where the data went. Let me see. I thought I did ingested the data there. Let me just quickly refresh. It just says it has KBs of data. Now, okay, maybe I cleaned something later on. Okay, anyways, so this is the one which I'm using right now, the only one. But the logic was that we will have one filter. There was a filter concept, and then the Azure functions which are running. So if you see this part of the diagram, the output of the Databricks goes in the ingestion ADLs, and from on top of that we have functions. Functions will be queue triggered functions. So the whenever these functions, so and this function layer will also scale out, right? So functions are the serverless functions which we have in Azure. In AWS we call them lambdas. So this is that thing, like Spring Cloud functions also. So this is that thing, and it will just scale out over here. Any programming languages, or a lot of programming languages are there. We are using Python right now, and this guy is the one which is sort of ingesting the data inside these different data bases over there. So if I show you my function, it should be lying somewhere in the resource group right now. And that's the one, this one, ingestion function. And so this is the wrapper. The function is here. Once it loads up, we'll click on the function icon over here. Okay, okay, okay. This one, data ingestion function. So it's a basically queue triggered function uh, which will get triggered whenever there is something in the queue. And how will data will go in the queue? Event grid will put it there. So if I just differentiate between these two solutions over here, you see this small event grid. That's a very important that's pretty important in Azure as such. Now, nearly every Azure service can talk to every other service, or if I put my words correctly, the events can be passed from one service to another service by using event grid mechanism. So we don't have to design it ourselves; we just have to use it. It's already there. We have to start using it, and it also contains uh, publisher and consumer type of model. So, for example, when the data will go here, then it will automatically pass the blob create event. So blob create event is that just means that the file was written there, so one blob was created. So this blob create event is the one which will be, you can say, published by the event grid or passed by the event grid on the queue, and then the function will take care of it whenever it can. And function will our Python functions right now, which will further scale up over there. A lot of them will come up, and they will start processing the events as fast as they can, based on the scalability, which as such. So that blob create event is being passed. So there is no, you can say, everything is sort of watching everyone else, and all the things are binded to other things, and things happen in a flow over there. Okay, finally, so this function is not one; it will further burst. Finally, we have more queues over there, and more functions also as such. Uh, and finally, what they will do is they will write the data into different databases. So 100 customer data will go in 100 different databases. So I have the cluster with me. So this instance represent that cluster, like which can be like 200 node cluster or 1000 node cluster or whatever you practically want to work with. You can specify that. Databases are the databases where data will be there. And we can get the data from various sources. You definitely can also directly get it from IoT Hub, Event Hub. Right now we are getting it. We have a different logic right now. It's a more practical logic. Uh, if you dump your data, if you dump your raw data directly inside any solution, I'm not sure how will you work with it. So practically things go wrong. Things doesn't work pretty well in life. So we have to take care of the corrupt rows, duplicate data, and so on and so forth. So we have taken care of that before. We have the landing zone, pre-processing, ingestion zone, then finally it's going inside the next solution. So but you can definitely directly also connect with it if that works out. So options are there. So Data Explorer will connect with these sources, and we will also have the external sources, and we can also read from ADLs. That's actually what we are trying to do right now. But it's a slight different example right now. Okay. Now, anyways, Data Explorer service of Microsoft can work with structured, semi-structured, unstructured, all type of data. We can create warm path, hot path, cold. You can say hot, warm, and cold path. So that the three tier Lambda architecture can be created over there, and anyone can use it. Data engineers can use it, data scientists can use it, analysts can use it. What do we do with it? We will be doing real time, near real time analytics over there. You can integrate this Data Explorer in your monitoring solutions. So the Grafana dashboards may be reading from here, or Power BI dashboards will be populated on the queries which are executing in the Azure Data Explorer. You can even have external application. So let's say you made one mobile app or some another application, and basically we have the capability of exposing the APIs, so it can go and read the data from there. Now, if you and just to give you an understanding of the capabilities, let's say you had another Spark cluster here. So the data scientist wanted to use the Spark cluster as such, or Azure Machine Learning Service, the main machine learning service in Azure. So if they want to use the Spark cluster, then Spark cluster can read from there and obviously can write back also if needed over there. So all the capabilities are available. A lot of connectors are there. It's a pretty, uh, we can say, solution which connects with a lot of things. So we can could have also directly streamed here. Uh, could have used IoT Hub, Kafka if it works out. Data Factory based ingestion is better. Data Factory can take care of the pre-processing in the various activities over there. So that one is okay. Rest is pretty, we'll see if practically works out. We can directly stream here. Otherwise, whatever we have done is better. Now, inside Data Explorer, if I zoom in over here, so query execution engine will be there. Column store. So what it does, it's a fully managed service where you can do analytics. It's very cheap versus Spark. So those who are thinking that why can't we do whatever we are doing over here in Apache Spark is because your cost will go will skyrocket if you run your Spark cluster 24/7. So which here will be very manageable, and it's a very sort of fully managed service which keeps the data in the local cache when it requires. It moves the data to the colder storage when it's not you can say when it becomes colder. I can have multiple cluster. I can run queries on multiple cluster. I can have multiple nodes also run the queries on multiple nodes at the same point in time uh, over there. And it has SSD based caching mechanisms. In memory mechanism is there, and normal disk based mechanism is also there, where we can store our data. So what are we going to do with it, right? Let's go in that part first. The and I'll just show it to you first. I will just show a couple of things. And if I take you back to my Data Explorer, you will notice we wanted to have 500 databases for 100 customers. So imagine it over to be there. And then, okay, let's click on one of them. Now I want to run few queries over here. So okay, so uh, let me zoom out. I'm not sure. Maybe it's because of heavy load right now in my laptop. Things are slightly slow. So hopefully you guys are getting my voice clear and there's not lagging. But okay, now we are not using this one, we are using that one. So right, okay, okay. So so what I did, this is right. So let me see if I can zoom in one direction. Okay, let's just push this back. We can go for that, the web UI. I have it open in my secondary screen just in case. Okay, now, so this is basically a type of query which we call as custos queries as such. And these are very simple single line queries over here, which anyone can write. It's more English type versus using any other programming language. You can definitely work with Python also. That's capabilities there that we can run. We can do the dashboarding with Python over there, and whatever company's data which I'm getting from various sources, this is going over here, and I can run these queries on that, doing any type of analysis on my data in real time. So if I show you more examples of this, to show you more examples of this, I will take you to the the Microsoft's documentation, and that's the one which we would like to refer to whenever we want any guidance over there. So big data analytics with Data Explorer, how can we do that? The monitoring solution with Data Explorer. So this is the one which is very useful. So if you have security operations teams who want to investigate, hunt, and then find the attackers in the environment and open incidents and investigate these incidents later on. So for them, the security logs needs to be stored for a longer period of time, and uh, we also may need the capability to get the data from many more sources. So this is where Data Explorer also help us out. So we will see that architecture and some other things as well. The IoT architecture is very popular. We will have a look at that. This is the one where you are working with the let's say maps. So imagine that you want to find, let's say if you are running, Grab uses this. Grab is the cab aggregator in Southeast Asia, like Uber. So uh, from their point of view, so imagine that the driver was supposed to pick up the rider from A location and want to drop at B location. So uh, the you can say that now is that so and the driver took some other path which is going outside some geographical location. So how can we find, alert, and notify? That can be done with these functions over here. Okay, now let's go and see a couple of examples of what we can do with Data Explorer and where can we use it and where can we integrate this. So if I take you to the big data analytical solution, so if you see over here, okay, so now, so one of the use case will be that the will be as part of the advanced analytics. So the machine learning models which are created in the Databricks or in Azure Machine Learning Service or in Azure Synapse, uh, the normal Spark one, those machine learning models can also run inside the Data Explorer, and we can do anomaly detection over there. We can have pattern recognition inside it. We can do time series analysis inside Data Explorer with machine learning as well, apart from the normal queries. Now, if some sort of anomaly was found, there was extra vibrations happening in the IoT device over there. The conveyor belt was running very fast, and the because of the speed, the vibrations were not there, but the vibrations were there because the conveyor belt's wheel had a micro tear over there. So that anomaly that vibration data which you are getting, if you want to find that forced vibration over there, which is the anomaly right now, inside that I can do here, and based on that I can integrate logic app also, which is not in the diagram right now, or maybe it's somewhere. but logic app can be there, which can further immediately notify the someone who's responsible for that IoT device that okay, go and stop the or reduce the conveyor belt speed. It's going to break down because it's having a micro tier also, or there's a major tier, and now we want to do some preventive maintenance, or we want to predict when we want to do the maintenance. So that anomaly detection can be done here in Data Explorer on in real time on streams of data, uh, without using Spark, reducing the cost as well, and in a very highly managed, um, scalable manner. Okay, that's one of the use cases which I can put just by looking at this. Okay, now if we go and have a look at the other one, so in the monitoring type of scenarios, so this is where we have Microsoft Sentinel, which is a tool which we have where which the security specialist can use to gather data, the logs data, events data, or any type of let's say risky sign-in data from Azure or other services, from AWS, from on-premises, from your firewalls, and so on and so forth. All the data gets gathered over there, and then the Data Explorer, which is having way more connectivity and way more scalability and and capability than from the point of view of running the queries versus Sentinel. We can use the Data Explorer for that unified analytical platform where the data from structured, semi-structured, and structured data is gathered from all the different locations: security logs, system logs, network logs, application logs, user log, DB logs, log stash, event hub. Kafka is also streaming here. Maybe it's going directly there. Maybe it's going in the storage account. Maybe here you have the functions which we are talking about and the entire landing zone in the middle over here where I'm moving the cursor right now. And then the analytics is going on here. The anomaly detection is going on here. The unusual behavior of the person who logged in the in this SQL server was done here. So if the token was was, let's say there was some token used to log in one of these services. So if the token was unusual, it was having more uh, uh, TTL than the usually what we use, or if we have if the user was trying to log in from some location which is not usual, any type of account based risky sign in happened, or any type of location based sign in risk was there. So all of that data finally was when it was gathered and captured, we can have analysis on that in real time in the Data Explorer. Now if we go and see the other options which we have. Okay, so this is actually similar to the previous one, but here we just want to understand that we can also do interactive, we can have the queries, the ad hoc queries which you will very interactively write with Data Explorer, and you can any person uh, who can, let's say, you can let's say run the query, get the output. That's what it means. So maybe there is a dashboard, you fill some values and you just say execute it, it runs the query, gets the updated value for you. Those type of interactive query mechanisms are also over there. Now if I take you to the IoT, but I'm pretty sure now you are already able to relate with what all Data Explorer can do. So the batch data, event data, IoT data, and machine learning capabilities, and it also will be able to expose the data through the APIs to different mobile applications who can get the data from Data Explorer. Spark can literally read write from it. So Data Explorer becomes that enriched or very rich source of data store where structured, semi-structured, unstructured data is available, and where other solutions can read from. So Spark can go and read it from there. And when we read from Spark, we can also do the filter. We can push the filter down in the query. We can say that, okay, Data Explorer, only show us company, let's say company data from this day to that day onwards. Don't load everything in the data frame in Spark. Filter it out first, then send the data. So all those capabilities are also there inside uh, Data Explorer. This is the one where we are storing the long-term security retention log data uh, from Microsoft's Defender, and from and Sentinel as such. Now the for the advanced threat protection. Now what we do over here. So for example, if you're aware of the cyber kill chain, like first the reconnaissance happens in your environment, then the attacker will try to gain will exploit the weakness of your environment. Then once they have exploited that, they will try to gain more you can say lateral movement will start happening. They will try to gain more. They will try to infect more services. So whenever in the cyber you can say cyber kill chain, or uh, the tools which are monitoring the cyber kill chains are these type of tools. We have the Defender, we have Sentinel, who can gather data from your Azure solutions, monitoring the cyber kill chain, and then you can also go and start running the ML jobs and the queries on top of it to further investigate the incidents which have happened, like how many user accounts are there where the password was tried to be reset, and somebody tried to do that 5 times or more than 5 times, and or how many times you want to find the number of people who were trying to log in, but the login failed for 5 times or 3 times or some X amount of times. So that's like a brute force attack. Somebody is trying to guess the password. So all that data, once we gather from all the locations, in all and these solutions connects with all the locations like AWS. It can get your data from GCP suite as well. The It can get your data from the other third party tools as well. So everything further gathered, and Data Explorer is the unified location where we are running the interactive queries, where the security expert is sitting and doing that. And then based on that, incidents are there. Logic App is running some further automation script to take care of it. Webhooks are there. Mobile apps are there which are reading, or some sort of application is there which is reading from here, or simple dashboard is there, or you are creating the dashboard with Grafana or Power BI and so on and so forth. Now, if I take you back to my diagram, so this is what I have over here, and the various customers' data is going inside the Data Explorer. There are a couple of reasons why we are going for Data Explorer. First thing is fully managed solution, very fast to onboard different teams, very fast to onboard different uh, solutions. So if I just take you back to my landing page over here and click and show you the various ingestion connectors which will be visible. So I can simply find it from somewhere here. Okay, so now all type of data formats, right? The You can have your data format, the various data formats, various type of data as well, structured, semi-structured, unstructured. And I basically clicked on the ingest new data option over there and just want to show you. So I want to load data from some location into my one of my database. So I can specify that I want to use any existing table or new table. I can specify that thing, and then from which sources do I want to get it. So this is like a direct connection. We are not pre-processing and then putting it over there. This is like it is going and then reading from some location. So uh, this is also possible. If we don't want to do other type of configuration, then we could have just simply clicked on this as well, and then uh, select the locations from where we want to get the data. So right now I selected the storage account, and so it's showing me storage account options. I can get from object storage also as well, file share, the entire containers, the event hubs, and so on and so forth. And then I can specify what do I want to read. So I want to read the data from the ingestion one, and then from which folder over there, and what are the filter rules. I want to read only company zero, one data should go in the database number one. So that is here. But the problem will be that if you so in our example we had 100 companies and we want to write data in 100 the different partitions wants to go in different databases. So then you have to create this connection a lot of times. It's better than you use some sort of you use a loop in Python in a function, and function will take care of it. It will pick up the data, it will write in the correct locations, and then it will also, if something goes wrong, we can also design the retry pattern with Azure functions. So that will be will be an improvement instead of doing like 100 connections over here for 100 customer, which will become very manual. But just to show it to you, we can also just get the schema something in this manner. and we can specify which format are we reading: CSV, TSV, Parquet, and so on and so forth, Evro, ORC, and others are there. And is it nested, not nested? Uh, is the schema mapping, do you want to manually do it? And if I just show this, this is a complex, this was the complex uh, column which we had. Now, do you want to rename it, update it, or do something with it? So ingestion solutions are there, the connectors are there by which we can ingest data from various locations over here. Now, more capabilities are visible on this this UI over here. If I take you back to the tab, you can see that we can create tables from the Data Explorer UI, and we can have external tables. These are metadata tables like Hive tables. They don't have data; they are pointing to the data, and whenever you need, you can pull the data. So you can ingest. That's what we are doing right now, and we can ingest from various locations. Retention policies on the data, because because otherwise the cost may also go up pretty high. Do you want to use Python with it or not? And we can also connect this with Power Automate, with Logic App. It's pretty practical with Logic App, with Data Factory as well. Data Factory can get data from various locations, write it over here, and do the ETL. So ETL part, Data Factory will do. Uh, Data Explorer is not an ETL tool, just FYI, and it will do the it will run the queries on your data, and it's a very rich source of solution, and connects with all these things as well over there. Now, if I take you back to my diagram, I just want to spend few more minutes, and then I'll just go through the any questions, and then we'll take care of it. Is that when things will not go fine, we have also implemented Azure functions. Like when errors will be there during ingestion, we have one Azure function, a piece of code, which will try to ingest for 5 times. If after 5 times, it will just put that in the poison queue. Like it will just put it in one queue, and we'll take care of it separately. We also have the error handler for Databricks, and this is the one which will take care of the bad files over there, and this is the solution which we are actually is recommended by Microsoft over here for very large customers for their data integration. And if I show you the final architecture, where yeah, okay, so this is the one where uh, you can say we also have you can say 3 queues over there. This is the one which we actually implemented, and this part could also have been done. Like in Data Explorer, we also have the concept of high availability by leader and follower. So leader, and we can create the cluster where others are followers as such. So read write copies, and others can also be provide the read copies as such. So it can also be made available over there. Now, this link is the one which I would like you to implement as such. If you just go to Azure and search for in their repository, just search for Azure Custos Lab, you will find this page. Otherwise, we'll also give you this in the chat window. I'll just pick it up and put it in the private chat so it can be posted by the admins on various locations from where you are connected right now. Okay, and okay, so whatever we have discussed is summarized here. The pre-processing part, the ingestion part, the Spark part, the metadata handling, the Explorer functions, uh, and how do we take care of the heavy loads, the scalability, the maximum availability, reduction of the cost as well. And this is the one which we you can say where we have the leader follower architecture, where we use the consumption based plan for the serverless options over there, and the entire details are in on this page. So this is the architecture which is implemented by Microsoft for the or the one suggested by Microsoft for their in large scale enterprise users. So this is what I had for the plan for the session. The links which we will post on the various platforms, please use those links to reproduce the entire scenario. Take your time, go through it. There are a lot of details into it. It's very production oriented, and And in case you have questions for me, you can find me on LinkedIn as well, and I'll be happy to answer your questions. And I'll just read through the chat.
Yeah, thank you, Shivam, for the detailed demo and for explaining it from the basics till the advanced level where Azure Databricks would fit in. And I think we have a couple of questions, Shivam. One is during your initial session, while your talk was about to begin, like what is part in the instance? Fred has asked. Maybe you would have told
Okay,
something about spot instance. Yeah.
the spot instances, right? Okay, so yeah, so we did talk about spot instances, and the spot instance concept is that if Microsoft is having extra capacity available in the region right now, for example, in East US, and if I go for spot instances, I will get the machines for my workload on a big discount. But the catch will be that if they need the capacity back, then those machines which they have allocated to me will be taken back, and I don't have a say in that. So the way we generally work with spot instances will be in a mix and match manner. Like we have two type of things, like dedicated instances and spot instances. So we make few dedicated instances, let's say 5, and let's say 20 spot instances. So things will keep on running you on the dedicated instances, and if we get the 20 machines extra, then your job will definitely will run parallelly. The time will come down. We can terminate the cluster faster, and the cost will also come down. So spot instances are very good for running things when we have a budget.
Okay. Which means kind of temporary low cost environments
Perfect.
in simple words.
Absolutely correct.
Okay, that's nice. Okay. And another user has asked, what are the use cases where Data Explorer can be used? But I think you have covered it from Azure documentation itself. Maybe could you
Yes,
please post that link where you saw those different use cases? Yeah.
correct. So this is the landing page, and this one is going in our chat right now.
Okay, I'll post it over here. Okay. Um, I have a question, Shivam. Like
Yes.
I'm able to see that Azure Data Explorer uh, can be fit into different use cases, and we can arrive into a solution quickly, like a solution in the sense provisioning the environment quickly. But would it mean data duplication, because we already been having data in data lake in some other places and again in Data Explorer? So what do you think about that?
Okay. Pretty nice. Okay. Uh, okay. Now I'll give you two answers for that. Uh,
Mhm.
and Now, so we when we work with data, we have various. So the one of the answer is, let's say we have various uh, different requirements, and data engineers, or sorry, let's say data engineers or data scientists want to read data, which they want to read data from various stages. For example, I have some raw data, or maybe I have some enriched or clean data. So I have some silver tables over here, and we have some bronze tables, silver tables, and then some gold tables are there. So now the data will be stored, raw data, curated data. So data will be stored, you can say at times, maybe duplication will happen, or we will be storing data in various, you can say maybe multiple times as well. Uh, but we also have the requirements on that let's say if we have gold tables, we want to use that data for BI purpose. If we have some sort of silver tables, we can do ML on top of it. We can get data from here also, or we want to get the data from there also. So the we also would like to provide the flexibility to all the different use cases, or all the different teams who are there in the company. And because of that, at times data goes into various, you can say, a different type of solutions. And mostly we have two-tiered architectures in the world right now, where we have the raw data is kept in some landing zone, like we have in ADLs, and then we move it to the final, you can say, the warehouse solution, or maybe to the to the serving layer or to Data Explorer or to another solution which can further do something with it and then provide the integration to the business logics later on. So those two-tier architectures or more than two-tier architectures are the ones which are prevalent now. And there are few things which we are called as lakehouse architectures, which are very popular these days, which further removes the two-tier architecture and which the audience can look for, uh, where that duplication will be greatly reduced.
Okay, okay. So, in a simple words, ML use cases might not be present all the time, but when it arises, simply we can provision an environment like Data Explorer, and once that purpose is solved, we can simply kill it and have the data lake as single source of truth all the time. Yeah, I think I can. I get it, Shivam.
Correct.
So I think,
And just to reduce the cost, Data Explorer also will have like the like in RAM option, more expensive. Then it will also have the SSD based cache option, and the third will be the colder storage accounts. So and then we can have retention policies. So yeah, we will be able to cater all the requirements for different team members and reduce the cost as well practically to what we can reduce it to be to as such.
okay, okay. So the pricing will be calculated based on the storage
Hmm.
and the services we use. The
Yeah,
more the ingestion, the more the cost. The less the ingestion, there will be no cost. Something like that, right?
yeah,
Okay, that's nice. Okay, I think we don't have any other questions, Shivam. Once again, thanks a lot from Chennai Azure User Group uh, team, and hope we meet soon again, maybe in person.
definitely. I'll be more than happy to come back for other sessions as well. And everyone, please do find me as well on LinkedIn. And if you have any follow-up question, you can reach out to me. I'll be happy to answer that. And join me for other sessions. I do a lot of other sessions as well. And have a nice day. And thanks for joining over the weekend. Have a nice weekend. Enjoy your weekend. Thanks, everyone.
Thank you.
Thank you, Dinesh, as well.
Yes, yes, Shivam. So I'm ending the broadcast. Thank you.
Okay, thank you.